so first we have Eshin, who's going to tell us more about GitHub.
Cool. Well, how many people here already use Git or GitHub? Most everyone. Okay, cool. How many people feel like they're an expert in Git? Good. I don't like it either, but I'm going to be telling you about it, so don't worry about that. Okay, so what I'm going to just do is a couple of slides to just use a metaphor that I sort of like to explain for people who don't use it, or maybe to help you rethink why you might use it. And then I'll do like a quick demo of a couple of things. In the Slack, I posted a link to a GitHub repository that actually has little GIFs of me doing commands in case you forget them. Other people in past years have found those helpful. So in case you don't remember what the commands are, you can actually see them being used in action and stuff. So, okay, so what's the point of what we're doing here? So you might, have some project you're working on and you have a bunch of files. Let's say it's called My Project, and you have a bunch of different analyses. And every time you make a change, you resave it as a sort of a new file name, version 2, version 3. This is sort of the conventional way. Maybe people have done stuff before they were ever introduced to this idea of version control. But we want to avoid this. And the reason we want to avoid this is because it's hard to know what the differences between different versions are, who worked on the files, what are the changes, and it's a little bit hard to keep track of things. So what we want to do is we want actually a system that allows us to easily keep track of our work history, but we also want to make it easy for other people to collaborate with us on these kinds of things. And we don't want to lose any of our previous work. We want to be able to flexibly jump back and forth between things. So the metaphor I really like is the idea of a time machine, and a collaborative time machine. And I think that's really the best way to sort of think about Git and GitHub when you're getting into it. It is hard to learn and master in that it has a steep learning curve. But what I found in my experience, I think most people, is you're only going to really be using a handful of commands most of the time, and you can just learn as you go for additional sort of needs, basically. So as Yarrick and other folks alluded to this morning, this idea is called version control, keeping track of things. And I'm just going to sort of do a few visuals to sort of outline what this might look like. So let's say that you're working on some file and you sort of saved a version of it, you do a little bit of work, you save a new version of it, you do some more work, you save a new version of it, and you have something that looks like this. This is our old way of doing things that we want to avoid doing. Instead, what we're going to do is we're going to use version control. And the way that that looks is we're going to have a file, we'll do some work on it, we're going to take a snapshot of that file, and this is in Git lingo called committing. And then we're going to do some more work, and we're going to take another snapshot of that file, another git commit, and so on and so forth. In general, throughout these slides, when you guys look at them, in red I've outlined what the command for Git would actually look like, and underneath them just sort of give you an example of what that means. Yeah?
Are these slides available online?
Yeah, they're in the Slack. I posted a link to where they are. Yeah. A little bit. So why would we do things this way instead of our old way? Well, one thing that immediately this allows us to do is it allows us to go backwards in time. So for example, let's say we actually want to undo version 3 and we want to go back to version 2. This is called reverting or resetting in Git lingo. And so our ability to do that while keeping track of everything makes this super flexible and easy. And in fact, you can jump back and forth in time as much as you want to, and Git is keeping track of you doing even the jumps in time for you. So it's super helpful. The other really nice thing to do is to sort of collaborate when we use this type of framework. So let's say I'm working on something and I have 2 different versions based on these sort of Git commits that I have, and I have a collaborator that wants to work and contribute on the same project as me. They can do what's called forking, and I'll describe that a little bit later, but they can basically make a copy of this repo for themselves, and then they can add some information to it, whatever changes they want to make, take their own little snapshot, and then they can send me what's called a pull request, which is, hey, a notification that I've made some changes. Maybe you want to integrate them into your version. And if I choose to do so, then the final version is essentially a blended integration of what I've done and what the other person has done. And again, the beauty of this is any one of these nodes we can jump back to at any point in time. The other sort of big use case for something like version control is parallel development. And so let's say you have the same idea here. You made some sort of software toolkit you're really proud of, some analysis or a new method for doing something. You create a version that you sort of release, and everybody in the world is using it now, and it's really exciting. And let's say that at the same time as people using it for sort of real with their own analyses, you want to add some more new features to it, right? What we're going to do is we don't want to mess up anybody's work that's actually relying on this toolkit, right? So we can actually create what's called a branch, and this is essentially a parallel timeline. And so in the parallel timeline, just like in every science fiction story, usually doesn't affect the original timeline, depending on who the author is. And so you can continue to do some more work in this parallel timeline, make a commit, you can do the same thing, make another commit, and the whole time your original timeline is unaffected. People are still relying on the version of your product. And so this can go on for as long as you'd like it to be. And at some point way in the future, you might actually say, hey, look, I have a new version of this. Everyone should use it. These are the updates. You can actually generate a change log from all of your commit histories, and then everyone can use your new project, and they love it. So I think this metaphor is useful because it allows us to sort of really think about working on things as having a time machine that allows us to literally jump forwards, backwards, and sideways. And we can include other people as much as we'd like along that journey. And at any point in time, we're very flexible to go back and forth. And so this makes things reproducible. It makes it easy to collaborate. And you don't have to worry about what you've done differently. Coming back to things, I'm sure everyone's had that experience maybe months later. It's like, who wrote this code? I didn't write it, right? But there's a version of you in the past that wrote it, and you can easily sort of look to see what's changed. The key distinction between Git and GitHub is that Git, by definition, is a sort of locally managed version control system, right? And GitHub, although there's other alternatives, allows you to sort of link this up with some sort of cloud service. And so GitHub is one of the most popular ones. It's a free service that essentially allows you to sort of keep track of your entire version tree, your entire time machine in the cloud so that other people can access it. And this makes it really easy for us to collaborate with each other and also to publicly release things. This can include analyses, this can include software tools, all sorts of things. You can also share any sort of text file. You could share data on GitHub too, but as Yarek was mentioning, the Git is not necessarily the best system you want to use to keep track of data itself. It doesn't handle sort of really recursive binary files really well, but flat text files, CSVs, and things are totally fine. It's not that you can't do it, it's just that it will sort of take up a lot of memory and be very slow, and so there's more efficient solutions like Git Annex and things like that for that. I won't be covering those. You can sort of talk to Yarek and other folks about the details. If working with the terminal and the command line can be a little intimidating, there are sort of GUI and user-based applications for this. So a popular one, I've never used it, is Git Kraken. It makes a nice sort of visual interface for seeing all these diverging timelines. If you use a code editor like Atom or VS Code, they have their own integration that allows you to sort of see very easily the changes you've made and all this sort of version history. All of these are also links too, so if you go to the slides, some of these are links to other more in-depth tutorials for the certain commands. I think the Atlassian one is particularly good. They explain use cases and the sort of core commands pretty well. And then the last one here is a cool paper, I think it was in PLOS, that really sort of motivates why you might want to use version control from the perspective of like an academic researcher. And so they go on to explain a lot of the different commands, but also really tie it back to what your typical workflow might be when you're just doing academic research. So I'd encourage people to check out that paper. Another bonus that I didn't mention that is pretty useful for a lot of folks is that Git allows you to sort of temporarily change files. Again, don't worry about memorizing these commands, but here's a reference for when people want to look at the slides later. But a common use case might be that, hey, I wanted to try something out and save changes, but I don't want to like break anything, so let me just stash them away temporarily, and then I can come back to them whenever I want to without messing things up. So Git allows you to sort of be very flexible to those things. So I'm going to do a quick demo of what I might sort of do with a very simple project, but I can take any questions about the slides if people are confused about anything. No? Okay, cool. So let me just switch over to this real quick. Right, so I just have VS Code open here, but on the left is sort of my file explorer, and on the right is a terminal. So I'm just on my desktop here. Everything I'm doing on the right, you should be able to see visually on the left. So I have a project called My Project, and I have 2 folders in there. They each have a file inside of them. I can just show you what they are. They're very exciting. And what I want to do is put this project under version control right now, because otherwise I would be changing file names and stuff. So the first thing I'm going to do is initialize the time machine, essentially, and this is called git init. And when you'll do that, you'll see this sort of message, and I have my terminal customized a little bit so it tells me and it's aware of the fact that it's a Git repository. So at this point in time, nothing has happened. All we've done is turn on the time machine, but it's not really keeping track of anything, right? And one of your most favorite commands that's going to sort of become useful is something called git status. That's going to tell you what the time machine is currently aware of, what changes are happening, and where you sort of are. And so I'll use this a lot. So this is basically telling me that you haven't made any snapshots yet, there's no commits, and that there's these files I see inside of this folder, but I'm not tracking them, I'm not doing anything. So if we were to do nothing else at this point, our workflow would not change. Git is not tracking anything, we're not keeping anything under version control. So if we want to make the time machine aware of these files, what we're going to use is the command called git add. And so git add followed by what we want to add will tell the time machine, become aware of this. So I'm actually going to just add the two folders that I have here. So I'll add analysis and I'll also add paradigm. Okay, and so if I type git status again to see what happened, you'll see that, okay, the colors changed, which is always a helpful thing. But B, it tells you that, hey, I have some changes that you haven't committed yet. You haven't taken a snapshot, but I'm aware of the fact that they're there now. So what do you want me to do next? And so again, if we were to do nothing at this point, nothing would change, but Git is now aware of these files. So what we'll want to do is take our first initial snapshot. And the way you always do this is the command git commit. And the only argument you'll pass to this is this -m flag and a message you're going to put in quotes. And what a message is just a little blurb about what this particular snapshot involves. There's a lot of sort of opinions about different practices for these, but in general, you're going to keep them pretty short, but they're going to be descriptive enough that you know what this particular snapshot referred to. So in this case, we're just going to say this is the initial project commit. And then I'm going to hit enter here, and you'll see that this happened, and it told me that it has created these sort of files under version control. So what I can do again is if I type git status, you'll see that nothing to commit, everything is clean because nothing has changed since the last time I've told the time machine to take a snapshot. But what I can do now is say, I want to look in the history of what I've done so far. And the command you're going to use to do that is called git log. So if I were to type this, you'll see down here, actually let me just clear this, it's a little at the top of the screen. So you'll see that this is the only thing that's ever happened in our timeline here. What Git does is it creates a commit ID, which is this long string of numbers here. It gives you information about the author, so this is my username on GitHub, and the date for when you made that commit, along with the message. So anytime I make a change to something, we should see it get appended to this log. So we can just try that out real quick. So let's say that I'm going to change my paradigm, okay? So I did that, I saved this file. Nothing has changed, but if I ask it, okay, what happened? It'll say, hey, I noticed that this file I was keeping track of has changed. It's been modified in some way. What would you like me to do about that, right? We can do nothing, but we can also take a snapshot at this point in time. And so now we have another sort of entry into our log in our time machine. And so we're going to do it exactly the same way. We're going to basically say git add that file. Okay, and if we do git status, it'll tell me, okay, I'm ready to take a snapshot. So we'll say, we'll do the same thing before. We'll do git commit. A message will say updated paradigm. And we'll notice we got the same response before. And so now if we look at the git log, we'll see that there's two entries here, right? These are two different points in time that we've taken snapshots. And we can jump between these freely whenever we want to, right? And we can go sort of backwards in time. So I'll demonstrate that really quickly, and you can sort of see what happens in the file on the left. So say this is a commit that I'm working with, and I want to actually undo this paradigm change. What I'll want to do is basically just get the commit ID, and then I could just say git revert and this. And it's basically popped up this thing, and it says that, hey, you asked me to revert this paradigm. Is there a this particular commit? Is there a message that you want to sort of add to this? And I could, if I wanted to, on my computer this opens up Vim, but this is just a text editor. I can just say, yep, that looks good to me. I reverted the paradigm, and I can just save this. And you'll notice that the file changed, and if I look at my git log, that I started with the initial project, I updated the paradigm, and then I actually reverted that change. So actually, even though these are two different points in time, the content that they contain is the same because we've just undone a change. So that's just an example of going forward and backwards in time. Does that sort of make sense to everyone? Cool, yeah.
I have one question, but presumably you've at some point set up Git such that the terminal knows that your account on GitHub is
Yep.
connected to it, right?
Yeah, that's right. Yeah, and so there's a command called git config, basically, which allows you to do that. And so there's a whole bunch of options on how to do that. If you go to GitHub, they actually have really good instructions for how to sort of configure those things. You don't need a GitHub account to use Git locally. That's only required if you want to do this sort of cloud synchronization. Does that make sense? You can have a local user, and you can have multiple users on the same system, for example, like on your computer, or if you have multiple people share the same computer, and they would have different user IDs and things.
Even without configuring it, you can use git file that has everything in it.
Yep, exactly. And I think by default it'll ask you about it. If you have nothing and no synchrony, it'll ask you about a username and stuff the very, very first time you use it and install Git. Any other questions? Yeah.
About reverting the commit, does it keep the previous commit basically? So theoretically basically if I want to revert back to the previous version, I could still do that?
Yep. So basically anything you can think about doing, you can do. I just showed you the simplest example. And so all I've done in this case is that I've undone a particular commit. And in fact, what I'm doing is I'm undoing it, but I'm keeping track of the fact that I'm undoing it, right? I could also say just roll back in time, but just don't keep track of that. I want to sort of not know that I jumped back in time, for example, right? And so a sort of alternate command is called git reset. And so that will actually change all of the files to a particular point in time, but it won't keep track of that. And I could actually undo the undo, if it's sort of what you're asking about. And so I could revert the revert and then get back to where I was. And depending on how I choose to do that, I can either keep track of it or I can ignore that altogether too. Yeah.
So commits have this like code,
Yep.
long code.
Yeah.
Can we just like revert using that code?
Yeah, that's exactly what we're doing. Yep. So when I'm doing the git revert command, you'll notice that I'm typing.
Okay.
That's exactly what I'm doing.
And so if there was something in the past future
Yes.
of the past,
Yes.
if I just know the code, then
Yeah. Yeah, so every time we take that snapshot, that commit, it generates one of these codes. So basically, you can move to any parallel backwards, forwards time position as long as you have committed at that point in time.
are there different indices with like a tree structure for the
Yep, it is a tree structure. That's exactly what it is. So when you have a parallel branch or you have these kinds of things, they'll have their own commits.
my git log shows the linear structure.
It doesn't have to though. It can show. So let's do an example like that where we'll create a branch. So let's say git branch. We're going to call this, new feature or something, right? And so it doesn't seem like it's done anything. All of these commands, these is the simplest way to use them. They have a lot of arguments that you can sort of skip steps. But if I look at git branch here, it'll show me that I have two branches and I'm currently sitting on my master branch. So let me switch over, and this is a command called git checkout to new feature, right? And so this has a new sort of feature in it. Nothing's changed. This is a really cool thing to use about Git, because when you're like working on your computer, when you switch over to a branch, all of the files will automatically change. So for example, if you're using a script or calling a function of some kind, it'll automatically pull from the correct place. So let's say I just like duplicate this line for argument's sake, and I just save it. Oops. And so now if I do git status, I'm on my new feature branch. It notices this has changed. So let me just I'll just do this, which is a shorthand for add anything that has changed. And so it's ready to take a snapshot. I'm going to take a snapshot, added new feature. Okay, oops. Okay, and if I look at my git log now, git log, I'm looking at the history of the branch, which inherits the history of the past. But if I were to, let's say, check out master, and I look here, let's see, oh yeah, git log. There's a couple of commands that, here we go. So you can't really see it based on just how I have things customized, but you'll notice that, sorry, one second.
So you're still using git log, just
Yep.
in different branches.
That's right. And so Git knows, for example, where was I here? Git log. You'll notice that like on the right here, it tells me that there's a branch here that a new thing has been added to. And in sort of a more GUI oriented way, if you were to use a different program or a plugin, it will show you the history of those things. I can show you, for example, the one in VS Code is this sort of thing on the right, which I don't think I'm using at this point. But it can, actually I'll show you this one, git lens. So this might look like overwhelming and super confusing. It basically keeps track of the different history of the files, but also the different lines. And you can sort of see that at this point in time, like these are the things that were changed. This line was added, this line was taken away. These are the actual values that were changed. And so this is an easy visual way to go back and forth to see sort of what exactly changed on a different
And then
timeline.
there's like a grandfather problem. So, you change something, uncommit something that was in the middle of the process. And
Yep.
the result of that was required for further things.
Yeah, so Git,
Interference with other
that's right. Yeah, so Git has this concept of merge conflicts that will tell you that. So Git, when you make changes and you take snapshots and then you pull in changes or branches, it will automatically try to integrate the changes for you. If it fails to do that, for example, because it thinks by writing, it does everything based on line numbers. So if you sort of write something to the same line and one thing would get overwritten, you'll get a message that'll pop up and say, hey, wait a second, I don't know how to negotiate this conflict. You do it for me and then tell me what I should do afterwards. Yeah, so it leaves it to the user then. Yeah.
So another question about the
Mhm.
because I haven't used it before. So imagine, like, let's say I have 10 commits,
Mhm.
and now we want to revert back to step 1 basically,
Mhm.
and then carry on from there
Mhm.
basically.
Yep.
Then all these 9 previous commits
Yep.
are like an abandoned branch essentially, right? Because
So it depends on
they
how you.
show up in the. I can't really imagine how they show up in the history because then it seems like a branch.
Yeah, so it depends on how you go backwards in time. So if you want to go backwards in time and keep track of your steps, you can do that in this sort of cumulative way, which is basically go back to this specific point in time, but add a entry to my log that tells me that I'm doing that, and it'll undo all of those changes, and sort of you'll have this thing where they're ordered in your log, but the actual times you change them might be different. But again, you can jump it back and forth any way you want to, even with that way of doing things. Yep. Yeah.
Maybe it's an evil question, but I can imagine the situation that I make a terribly embarrassing mistake and I don't want to keep it tracked in the cloud.
Yeah.
Is it possible to turn off tracking?
Yeah. So that's right. Yeah. So you can. I don't do this very often, but it's this idea called rebasing in Git. But yes, you can alter your history if you choose to do that. And one of the beneficial reasons that's not sort of nefarious might be that like when you're uploading something to GitHub, because it's keeping track of the file changes, sometimes the files will get very heavy. If like let's say you accidentally committed like a big nifty image, for example, right, and you don't want that there anymore. Now, even though you delete it and like push up in a new timeline, it's not there, the history of that file still exists, so it's still taking up some space. So that would be a situation where you go back, undo the steps, and sort of delete it that way. Cool. So I'll just show you how we can sort of sync this particular project up with GitHub. Yeah.
Yeah, so maybe this is the question. I just initialized repo on a folder, and then I realized that I actually wanted to go one level up in the folder hierarchy,
Mhm.
folder structure.
Mhm.
Do you just create a new one?
Yeah, you can. I would probably just delete it first if you really don't need that. You can do that. So basically what Git is actually doing when you init something is if you just look at the thing, you'll notice that it creates this .git hidden folder. And so if you were to wipe this folder, it would basically obliterate the time machine. That includes every snapshot you've taken and all of the changes and stuff. And so in here are where all those changes are stored. So if you do it accidentally, that's an easy way to get rid of it if you want to. Yep, I would just delete it manually if you want to do that. If you know for sure you don't need to keep track of anything and it was an error that you don't want to create it. In general, though, this idea of nesting sort of Git repositories is something that is built in by design, and it's called submoduling. And so a lot of times you'll have a project that depends on some other project that you change, and you're sort of independently working on them. And you might want like the top level to sort of depend on a particular version of the bottom level while you're continuing to work on that bottom level. And so you can sort of nest them in that way if you want. Cool. Okay, so I'll just show you a quick GitHub thing here. So right now I have this, I have my Git log, the changes I've made, but I can't, this is sort of, no one else can work on it because it's stuck on my computer. So let's change that. We'll go to GitHub. And so here is my GitHub sort of repository. If you haven't, let me back up for a second. If you haven't created an account, I would sign in, create an account. But when you sort of sign into your page, you'll have a sort of a bunch of options at the top. These are different repositories I'm working on, but you can also click this green button called New, and it'll ask you what do you want to call your repository here. And so I like to name them the same thing. You don't have to name them the same thing if you don't want to. So I'll just call this my project. It'll let you know if that's an available name. GitHub also lets you make repositories private or public. Public means that anybody with that URL, irrespective of whether they have a GitHub account, can access it. So it's really nice if you want to make things available, maybe they're analyses for a paper or tools or something like that. But you can also make things private, which means that you have full control over who can access that. You always have the ability to access it, but then maybe you want to invite particular collaborators, and they're going to have GitHub accounts to do that kind of thing. Usually you have to pay to have the ability to do private repositories, but GitHub has a student pack if people aren't aware. You don't actually have to be a student, you just need an EDU address, and they'll give you unlimited private repositories, and they sort of ask you to re-up every 6 months or a year or something like that, so it's a handy thing. Okay, so let's create a public repository. Because we've already initialized the repository, it tells us you can sort of ignore this step if you want to. And what they're basically saying is, do you want us to put any files in this repository on GitHub for you? A good practice is to create a README file which sort of talks about what's in that repository. GitHub can do that for you. I'm not going to do it through GitHub in this case. We'll do it manually. but we'll just hit create this repository. And right now this is sort of empty, nothing's happened. And you'll notice that GitHub is really convenient because what it allows us to do is it'll give us a bunch of commands that tell us how we can sync up our local Git with GitHub. And so since we've already done a couple of them, we've already git-initted something, we've already added something, we've already committed, really we can just sort of resume at this point in time. And so we're going to use this command git remote add, and then we're going to sort of plug in this URL here. So literally all I'm going to do is copy and paste this into my terminal where my Git repository is. You'll notice nothing has happened. But what I've basically done is I've told the time machine, this is a remote location that I want you to sync up to. And the way I do that is by using the push and pull commands. So the git push command is going to send my time machine up to the cloud. So I'll just do that right now. And we're going to just do this. And you'll get this sort of thing where it's literally uploading the files. And it's told you that, hey, this is the URL. What I've done is I've created a new branch called master, and I pushed that up there. And so if I go to this page and I literally just refresh it, you'll notice that I have my folder and I have my files in it exactly how I had before, but I can also sort of see the full history of any sort of file that I've changed. So if I go to the paradigm file here, for example, I can go to the history of it and I can see all of the exact things I did locally. And so GitHub in this way allows you to both keep control of this time machine, but also in a sort of publicly accessible way if you so choose. Yep.
Because like, for example, if you finish a project and you want to put it online for people to see,
Yeah.
is there a way to hide all that history, the commit histories,
When you're pushing it up, there is a way. I don't remember what the command is off the time, but you can sort of send a repository to the cloud without sort of, like basically you would tell it to push to the cloud with retaining the history from this point only. Yep. Any other questions? So I'll just show you one more thing and then I'll just sort of wrap up for time. But let's say that there's a project that exists already. Maybe I'm collaborating with someone and I want to work on it with them, right? And we're going to work on this one, this exciting cat study here. And so this happens to be in our lab repository because we study cats in the lab apparently. And so what I'm going to do is I'm going to fork this repository. And what this basically means is that I'm going to take an existing GitHub repository, so it's in the cloud. I'm going to make a parallel copy of it in my account that is completely independent of the original one. And what I'm going to try to do is work on that myself and then sort of send over a pull request, which is notify the original owners that I made some changes. So this is how that looks. So I'm going to fork this. It's going to say, where should we fork this? Because I'm part of a few organizations, it gives you the option. I'm just going to put this under my personal account. You'll notice that it's literally just going to clone everything over, and it gives us a nice little identifier up here on where we originally copied it from. So now what this is basically an identical copy of the original repository that's in my account and sort of desynchronized. So any new changes that are pushed up to the original one will not automatically get imported into mine. I can always do that if I want to, but this gives you control of how and when you want to do those things. Okay, and so now to work on this, what I'm going to do is the opposite. I pushed something up before, now I want to pull it down. And when you don't have an existing repository already on your local computer, this is called cloning. So I'm going to click on this button here, and GitHub conveniently gives you a URL. So what I'm going to do instead now is I'm going to move into let's say a different folder here. So now I'm just on my desktop, and I'm going to type git clone this. And you'll notice what it's doing is it's just going to download this repository here. So I'll just close this and I'll go into, you'll see that it created this folder. I'll just go into that folder and you'll notice that it has the same files that were on GitHub, okay? And so let's just open that folder here. I'll just open up a new window for argument's sake. So here's some file that I have. Maybe I'm going to change it, okay? And I'm going to do the same exact thing. So if I do git status, I'll just open this a little bigger. You'll notice that because this was already an existing Git repository, it's aware of the fact that this file changed, right? And so I'm going to say, yep, that's the change I wanted to make. So I'll do git add that file. Okay, and if I do git status again, just to show you, it knows that it's ready to take a snapshot of this. So I'll say, okay, let's take a snapshot. And that's done. And again, if I were to look at the git log now of this, this is an example of what I what I was sort of talking about earlier. So there's a whole bunch of stuff prior to today's date that other folks have worked on already, right? But you'll notice mine is way, way up at the top because on this date, I've sort of added something to this. And this is to Ida's question, how it sort of is visualizing different branches and forks. You'll notice that they have these sort of, like in this particular customization of it, it has these sort of like branching timelines that reconverge to the original one, to just help you understand that you're actually working on something at some point in time, and then you merged it back into the original timeline. And so now what I can do is basically say, okay, I want to make the original folks aware of my changes. So I'm just going to git push this back to my repository. And so it's uploading my changes. If I go back to this page, which is again under my account, I'll just refresh it. You'll notice that the commit message that I just added is right over there. And what I want to do now is make the original owners aware of this change. So I'm just going to click this button here called pull request. And what GitHub is going to basically do is say, okay, on the right side is your forked copy, your parallel copy of the original. Here's the original. And you want to basically make them aware of the fact that some change in your master can be added to some change to their original master branch. And so I can just click this pull request button. You might want to add some comments. People can sort of interact any way they want to here. And I can click create pull request. And so now you'll notice that it's taking me back to the original repository that I forked from. And you'll see that this pull request tab has the number 1 on here. So again, this is the original repository. I just go to pull request, and you'll notice that, hey, this person has just requested a potential integration. See if you want to add it. And if the owners think that this is great, they can just click the merge pull request button, and they can add any sort of message they want to about that merge. And now the original repository has been updated with the changes that I've added to it. And so that's another pretty typical workflow. You guys might use that here. You know, one of you is working on something else, and you want to quickly sort of synchronize your work. Yeah.
I thought pull request would update yours, but if they have a new version, they could update yours.
No, you have to do that manually. Yep. So often what's going to happen is that they'll change something while you're changing something, right? And so one of your commits is going to be all the changes that you've done, then pulling in their latest changes, and the pull request will update live to reflect that, basically. So anytime I add, if I were to have not integrated that pull request, anytime I make new commits and I push them up to my repository in GitHub, GitHub will automatically know that this pull request has changed somehow. And it'll just append in the same way that GitLog does all of the new changes that I've made. And one of them could be pulling in their latest changes, like you're sort of asking. Yep. Yeah.
So just so I'm clear, this is not changing, I love this timeline example, this is not changing your alternate timeline. So having having Eshin under the main Eshin has accepted the pull request. If you go back to your other window and do git log here,
yep.
if you did git log here, it will not
No, because this is just a log of my own personal timeline. Right, exactly, yeah. If I were to be working on the original project and they pulled in, they would see that that has been merged in at some point, but yeah.
So if you've been doing this and now you've merged with the original timeline, how do you switch so you're now working on their time? Now that your branch is done, how do you close this branch, ignore this timeline, and start from the beginning?
So if you forked it independently, you can just delete your fork if you choose to do that, if you feel like you don't need to do that anymore. More often what you'll do is somebody else will add, I would need another user to show you an example of this, but somebody might add something to the original one, and then I want to basically sort of synchronize mine with the updated changes from that. And that's basically called sort of pulling in the changes from the master. And so basically, when I were to do that, then my timeline would now reflect both their new changes and the fact that they integrated my changes. Yep, exactly. So I could do git pull the origin master. So basically just like so right now my local repository only knows about the fact that I have these. But what I could do is I can tell it, I think it's git remote add upstream master. And so this concept of upstream is where I originally forked from. And so if I were to add the URL for that, then I could say, hey, pull from that place, and then it'll automatically do its best to merge them. Yep. Anything else? Cool. So those are the main things I wanted to show. Sort of just the collaboration, sort of fast forwarding, jumping back in time. Working on separate things locally if you want to. I'm happy to answer more questions like throughout the week if you guys are running into them. Feel free to play around with like the GUI if you want to sort of get your bearings first. So the one that I think a couple of people really like is Git Kraken. And so it's a sort of much more visual. You can sort of already see this sort of tree timeline kind of thing. You can click everything button-wise if you prefer to do that and you don't remember the commands. I never remember most of the commands myself. And then if you're using like VS Code, there's something called Git Lens, which basically is another sort of thing that allows you to see different changes. So for example, you'll notice that my code editor already tells me that a few seconds ago this particular line was added by me. I find that very convenient. If I'm working on a large code base or some analyses, I know who did what at what point in time, and I can always sort of jump back to any of these time points like from my editor if I wanted to very easily. So encourage you to sort of play with those things too. But, yeah.
What editor is it?
This is VS Code. Yep. But Adam, I think, has a similar type of a thing maybe. Yep.
What is your, I guess, philosophy, or I mean, maybe also other people's philosophy, of how to commit, how often to commit, kind of which changes to commit, how, and so on.
Right. Yeah. I've heard a bunch of different philosophies on this, and I think people probably differ. One that sort of comes from the software world is commit as often as your commit message doesn't get too unwieldy, basically. So if you feel like you've made enough changes that you couldn't type it into essentially a tweet, then you should commit more often, basically. So you can sort of move in time there. Maybe that may not work for everybody. In general, I try to commit pretty often, and the frequency is going to depend upon, I think, your workflow. I think if you know that you want to do some sort of critical thing, you definitely want to commit and make sure everything's ready beforehand. That'll be something you'll sort of work out with your collaborators, is what I would say. I don't know if other people have opinions on that, and I'm sure different philosophies.
It correlates with Big Five personality traits.
I hope not, yeah. Wait, did Big Five correlate with anything? I don't know if they...
Maybe with like Facebook stuff.
Oh, really? Okay.
Friends.
Maybe Facebook knows
How
then.
can you text your friends? How
Yeah.
can you commit your code?
Yeah. Yeah.
Is there like a style guide for what your commit message should look like?
I'm sure there is. I don't know what it is, though. Yeah. Yeah. Where there is a cool software system, there's an opinionated software developer, so I'm sure there's... Yeah.
Often on like the software package, if you're contributing to somebody's, they'll have a thing for contributing and how to do the commit messages. So
Yeah.
you might have code for
I'll show you like...
fixes or updates or documentation.
Yeah, so I think like, for example, maybe, I don't know if Nylearn does. They usually have this. Yeah. So you'll notice that this is NumPy, for example, right there. All their code is available online. And let's say you encounter some bug or issue. If you want to notify them about them, they already sort of provide this template for you, which is like, please tell us how to reproduce your error, what it is. Otherwise, we're not going to even take into account because we need to be able to do that for ourselves. So you as a software developer or an analyst have options on how you want to sort of choose that. But I think that's a nice way to sort of do things to keep them manageable. I didn't mention this, but yeah, when you're on GitHub, there's this concept of issues too. There's a bunch of other things it can do, but issues are really nice where other people might be using your sort of software and they encounter a bug and they can notify you about it, and you can organize how you want to prioritize these things. I know some people actually use it for doing pretty sort of clever things like tracking papers or sort of steps in analyses that they have to do. You can sort of feel free to do whatever you'd like there, I think.
Do you get very slow with VS Code when you're using Git on it?
Using Git Lens on it in particular?
Yeah.
I haven't found, I mean, my reference point is Atom and it's just already faster than Atom, so yeah.
Because I moved back to Sublime after like 2 months of using VS Code.
Yeah.
Because it got very slow. Maybe your laptop is faster or something, but for my old 6 years old laptop.
Right. Yeah. Yeah, it's going to be,
Deleting things like the modules that I had added on.
I have a
They were super convenient initially. I don't know if it's like.
mm-hmm. In general, I would say that there's a trade-off between speed and how much you want to customize your working environment. And I think this applies to basically everything. The more you customize it and the more it has to do a lot of things to sort of prepare itself for your customization, the slower and heavier it'll be. And that's just a limitation of how a lot of the tools are built, I would say. I'm happy to, like, I have a lot of opinions on this stuff. If people, like, on the other day want to, I think we're doing software tools for research or something stack. Yeah.
Yeah, we'll do a breakout session with
Yeah.
like kind of tools, like tips of
Yeah.
like what types of editors or cool packages that people use that you might not have heard of.
Yeah.
The reason I asked is if you have a Git lens that separately has all the sort of history, that means more cache, and that means just more
Yeah. Mhm.
space loss.
Yep. That's right.
One thing that's super convenient is Gitk. It's a very low memory thing that you can install, and the GUI is very basic, and it shows branching very nicely.
Mhm.
Okay, so not related to.
It won't be a plugin for your editor. It's
Right.
like a separate thing.
What is it called again?
Gitk. Git and then just K.
Any other
Anything
questions?
I guess, I just, for anyone, does anyone use Git with LaTeX?
Yeah, sometimes.
Get with, you mean just repeat it so it's.
Oh, Git with LaTeX, like the the scientific writing language. Yeah. Yep. Yeah, it works fine. In fact, actually, it works way better than some other alternatives because it's basically code, right? They're flat files, and so it has no issue doing that. Some people really like it. I think Overleaf, which is like the interactive editor, they're actually doing a version of these sort of operational transforms, which is this diffing operation that Git does when they're showing you line changes. So it actually works really well with that.
You can
Yeah.
sync it with GitHub too.
Oh, that's cool.
The Overleaf also has added an edit option, so some of the history
Yep.
is in fact even visually represented in the edit options.
Mhm. Yeah. Yeah. I know a lot of people use it with LaTeX, I would say. Yeah. Like it's way better than.
Want to talk a little about your workflow with LaTeX and Git?
Sure, yeah. I don't know if there's much to talk about. Like, you make a full, like, it's the same as any other. Oh, we do have one interesting piece of it. So it's the same as any normal project. So you have like your text file, and then that's kind of where your paper is. And then we have a bibliography file, like a .bib file that's shared by every paper and project in the lab. And that's a different repository. And we add that as a module to any paper we're writing. So that allows us to maintain one bibliography, and then if we want to add a paper to that, or we want to cite in like one of our papers, that'll be available for any current or future paper that we write. So that I found that.
That's a nice bit.
That's very useful.
Yeah.
So we have the shared instructions
I
for
think
that lab's GitHub page if you want to.
I think
Anyone else wants to use that?
How do you maintain the bib file and like the
Oops.
associated files, like the PDF or whatever, or is it just you?
So yeah.
Was it context?
So it's
Oh, there it is. Definitely was. I was like looking at this the other day.
yeah, there it is.
Yeah.
So that README file tells you how to set it up.
Mhm.
Open a big file so to answer that other.
That's a huge file. I don't think it's,
Ooh,
I think it's possible.
In Overleaf you can just
Oh,
you can
okay.
see.
Yeah. So GitHub by default will try to render things, and sometimes it can't based on the size and stuff. It can natively render PDFs, and it can render Jupyter notebooks, for example. And then you can always just look at the raw contents for any file. Yeah.
So if people use Zotero, it's actually easy to just have it on your browser. You click the library, and then you can export it in the bibx format, and then just paste it in your bib file. So it's very easy to add things, get it out. Because some websites do allow you, some journals do allow you to just get the bib format, bibx format, but some of them don't.
Honestly, Google Scholar does that too.
Yeah.
You don't need Zotero. You can just use the standard Google Scholar.
We something we found useful, or I found useful. I don't know if Lucy can speak to whether it's useful, but we have like a kind of consistent format for our citation keys, so that you don't have to look up every paper you're citing. If you know the author and the year, you know there's a kind of a direct mapping to a citation key.
Nice.
That's important.
That's cool.
And so that's not always the case with like a Google Scholar
Mhm.
No, because
export.
Dave is
No,
very- yeah.
But the Google Scholar, what I do is the Google Scholar pulls down most of what you need And then with tiny changes, you're done. But yeah.
Yeah.
What's your naming convention? Like first
So
author,
we use, so it's up on the page, but we use the first first four letters of the first author's last name, and then if there are two authors, then we use first four letters of the second author's name, and then 2 digits of the year. If there are two or more authors, we say like
To the year, didn't you learn your lesson
et
last
al. 19, something like that.
some same authors have like multiple papers a year.
That's right, and so we append a single letter after that. So if it's like man et al. 19A, B, C, etc.
Or woman et al.
I've never encountered more than 26 papers with the same convention.
26 papers in the same year?
Right, because then you have the A to Z.
That's right.
Mendeley also does
Yeah.
a consistent naming convention with their exports. It just does, but it also uses the first word of the title.
Yeah, I like that. That's how the Zotero does it too.
I think like papers and paperpile also give you the option of how you want to build your site keys when you export. So, and I think it does a similar thing to what you folks are doing.
It is useful because like if the paper starts with, the title starts with hippocampus, it would be like
Right.
SAR something and underscore hippocampus underscore 18. So even if they had like 5 papers in 2018, unlikely all of them started with the word hippocampus.
The other use case I'll just point out, I learned from some other folks, is if you're customizing different programs that you're using on your computer, so like I like to have default plots in Matplotlib some way, I have my Jupyter Notebook customized. There's this convention of a .files repo a lot of people like, where they'll commit all of their customized RC files, Vim or whatever it might be, and then this is super neat when you want to move to another computer, you can just clone this down and then you're good to go basically, which is super handy, I found. Yeah, it's to keep different computers in sync and things. And actually, I think Atom and VS Code both have an option to do this, and this is actually literally what they're doing behind the scenes for you. So, also, like if you're running experiments on multiple computers, I know some people like to keep scripts in Dropbox and stuff, but you can also just make changes on a machine, push them up, and then quickly pull them to the computers, like locally your experiment computers and stuff. So, it's another use for it. Yeah.
So I've only ever used GitHub, but I know there's also like GitLab and Bitbucket and things like that.
Mm-hmm.
Are there like significant differences? Who looks a bit better about one?
In general, they're all trying to accomplish the same process, but they vary in a couple of dimensions. One is like how much control they provide the users. So let's say you wanted your own instance of like a cloud type thing like GitHub, but you want control over the server, right? For example, right? I know GitLab and a couple of things allow you to basically just prop up your own instance on, say, a local machine in your lab or your department and things like that. Others are sort of just like the perks they give you in terms of privacy and so on and so forth, and their philosophies towards who's allowed to use the service and things. I know, so GitHub got bought by Microsoft, which has been like a sort of questionable thing, and for the most part they've been okay, but then recently there's been some issues particularly related to the travel ban, where they've been sort of indiscriminately banning users based on IP addresses from countries the US has a travel ban with, and it's frankly ridiculous. So, you know, some people are not using GitHub just sort of out of protest for that. So, and I know the companies differ on their opinions about those things.
Just a quick comment on that. Many universities have intra-university GitHubs, which are essentially complete GitHubs, but all just run within the university. So you might check to see whether your institution has one, because then it's local and the public is within the university itself. It would be easier particularly for lab-based, but obviously once you want to go public, something to think about.
Historically, it was they all had different like numbers of users for free accounts, but I think GitHub they offer lab accounts and student accounts and faculty accounts, so they're pretty generous I think with the number of private cloud services we have. I don't know, is anyone else use GitLab, or we used to use Bitbucket a lot more?
We migrated from Bitbucket to
Yeah.
What was wrong with it?
so more people are using GitHub, and so we found when we publish things to GitHub, we just got a lot more users.
The other thing worth noting about most of these services is that they allow really nice like hook integrations, what they call them. So let's say you're writing a software package, and Yarg mentioned writing tests. Now you can have your tests that are set up to run locally, but you can also say tell GitHub that every time I push something, I want you to quickly run tests in the background for me. And so you're immediately notified, for example, in the pull request example, where I might have made a change I thought is good to go, but all of a sudden it fails some test in the main repository, and then the original author might be like, wait a second, you need to fix a bug that you weren't aware of. And so these sort of automated things to happen whenever you push and pull to GitHub is super convenient. Yeah, so like our lab repository here basically has these badges up here, which you can sort of see, that are built mostly automatically. But you'll notice one of them has this build passing. And what that's doing is it's using this service called Travis CI. And so anytime you'll notice that these branches or changes have been made, it automatically runs tests associated with every time we do this. And so this is super handy because, you know, I might think I added a new feature, but I inadvertently broke something else. And so like you'll find most open source tools in Python that are heavily relied upon have very, very sort of rock solid continuous integration sort of frameworks, which is this idea of automated testing, like NumPy and everything. And this is just because sometimes you won't know if something you did in the future actually ends up breaking something in the past. And so this allows you to make it quite easy to do these kinds of things. And there's instructions on GitHub on how to do this, but most of it amounts to literally just adding a single file in your GitHub repository basically here that just tells it to build essentially a quick Linux box and to run specific Python commands or bash commands. And then as soon as GitHub detects this file, it'll just do it for you. So it's pretty, or like automated, you know, sort of package distribution for different Python packages and so on and so forth. Yeah.
You might have mentioned it, but is there anything for like automatically committing every 10 minutes or?
Not that I'm aware of actually, and I think not, because in some ways it goes against the philosophy of how it's sort of designed to be used. Yeah. Mm-hmm.
Does it have to recreate that environment every time it runs the tests?
So you can, that's an option you can set if you wanted to cache certain versions of things like that to speed it up. But if by default, I think it will try to do that. Yeah. Mm-hmm.
You can make different versions if you want.
Yeah.
Just look at that.
Yeah. So some of the questions this morning, like if you want to make sure your software works for several versions of Python across different machine types like Windows, Mac, Linux, you can set those as flags in your testing config file. And so it'll run tests on everything, and you'll be like, oh, the Windows Python 2 version isn't working, but everything else is fine. So, yep.
Might be worth just kind of talking about like how to like deal with like sensitive information like passwords or like authentication tokens and stuff
super
like
important.
this.
Yeah. So one thing to be aware of is that because GitHub, remember, is keeping track of not just the files you've committed, but the history of everything. You know, like everyone inadvertently will do something where they'll sort of commit, let's say, a file that contains passwords. Let's say like an SSH key, for example, to a server, or, you know, some user account for, like we use mturk a lot for things, right? And so like there are bots that absolutely exist that crawl the internet for public repos that have passwords, and they will just run your money down. Like they exist, right? And so GitHub tries to quickly notify you, I think you've committed something that actually has sensitive information on it. And the sort of process for dealing with that, and there's tools to make it easy, is to actually nuke the history from that point forward, right? Because again, you can delete the file, but they can go back to the history of the repository. So it's worth being very careful about doing that, which is also related to this idea of ignore files. So I didn't do this in the demo, but if in any repository you add a file that starts with .git ignore, this is a special file name that Git becomes aware of. And you can basically tell it to ignore these files. And so this is a nice way to sort of make sure that there's folders or files that you don't ever want Git to add. And it'll just basically act like they're invisible. So adding this to repository is another way to sort of guard against, you know, adding sensitive information or junk files or what have you.
We've racked up thousands of dollars with first-year students making this mistake on Amazon AWS instances.
Yeah.
Wait, how? What happened?
So like within seconds, a bot had grabbed it and had already scrolled up a server with whatever they were doing, and the student didn't know, and they thought they deleted and scrolled it, and they didn't realize it.
Yeah.
And then we just got these outrageous bills.
So the student accidentally uploads their account.
Yeah, the
Some
key.
bot comes in, uses their account to log onto your AWS server,
Yeah.
and then uses your AWS server and
to like mine bitcoins or something. Yeah. Yeah.
See, there was an old system. We had a laptop. It was off the internet.
Yeah.
These things weren't a problem.
To be fair, I only used it for 10 minutes.
That's like 10% of your cut. Any last questions? Otherwise, maybe we'll move on.
Yeah.
Is this just a text file that you can make?
Yep, that's right. Yep.
In like the root folder?
Yep. Dot get ignore. Yep, that's it.
And what did you have to enter for getting on for that to get fixed? What was the fix?
Oh, so you have to.
Yeah.
The real thing. That one was just handy.
It's like.
Cancel account, get a new key. I would just do that.
I think it's like get BFG or something like that.
You have to do
But
that.
to prevent it, it's like dot get ignore, and then you put in it what you do.
There's a lot of ways to do it. You could use get or ignore if you want to keep it. Now we just kind of have a policy where you just don't keep passwords in that. So you'll have another folder with it, or you store your passwords or your keys in your environment, which is also not safe, but for other reasons. It's like if you're in your Unix shell, you can have like a whatever variable name equals this, and that's your password. You can just call that. This is more for like web app development. So if you don't do that, you wouldn't have this stack.
Mm-hmm.
Sounds like it should be a PSA or something.
Yeah.
Yeah. I think.
Those are the PSA right now.
Yeah. Surprise. But yet, GitHub tries to tell you you have vulnerabilities. It's not. It's pretty good. Like it picks up like SSL stuff. It picks up SSH keys. It'll pick up package dependencies that it knows has vulnerabilities and things like that. But I wouldn't rely on it entirely. This is the sort of tool that's pretty good. The commands to sort of clean your history in this way are kind of annoying. But some folks have built like tools like this that basically will go and sort of wipe really large files if you sort of accidentally committed a nifty or sort of sensitive files of a particular type. Yeah.
This is also seems like more of a problem for public repos.
Yeah.
If you have private repos, then go ham, I guess, with your password.
Well.
If you're using the server, like the.
Yeah. So the question is like, what happens if 6 months from now you make your private public because the paper's available, and you don't remember, right? So, yeah.
I would just make a separate repo just for like the public version of the
Mm-hmm.
of the thing.
Yeah.
Good idea. One of the issues has been there's this lot of issues now about like, oh, we're supposed to show the whole history, but actually the history is the paper, right?
Mm-hmm.
So it might make a lot of sense when you publish to not publish the history, right? It's like we were saying, when you push the thing, what you want to push at some level is the initial, we're starting here. You could do that when you're starting that for turning it from private to public.
Mm-hmm.
It's often a good idea to start from scratch. Say, I know we're done here. It's like an initial commit, right? It's like you've done all your private stuff, put it aside, create a new public one. Probably good practice.
Yeah.
Just one thing unrelated to this that I mess up all the time is that adding a file to git ignore will only ignore that file if you haven't started tracking it already.
Mm-hmm.
Unless you go and like prune and filter everything.
Yeah, right. Yeah, again, I think it's helpful to think about this in the time machine sort of analogy, because the history doesn't change just because you change something now, right? The past is there. So if you change something now, you should go back and wonder whether you need to also change it in the past. I think. Okay, thanks guys. Yeah.